This video is on creating double line graphs and using them to find the rate of change. For a double line graph, you are going to need a title, a key so that I know which line is which. You're going to need labels on both of your axes, and you are going to need consistent scales. So what I mean by that is if you go up by 12s the whole time, you have to go up by 12s every single time. You noticed on review number 1 that the first increment was 12, and then people went up by 8s because that's what the table said. But that's not a consistent scale. If you're going to go up by 12s, you have to do it every time. If you're going to go up by 8s, you have to do it every time. So the first one I have is Emilio going on vacation. His mom and sister leave at 7 a.m. in the morning, driving an average of 45 miles per hour. Emilio and Dad leave at 8 a.m. His dad drives an average of 60 miles per hour. So with a double line graph, it's important to have a table, and we'll have time as our x-axis variable, and we start this at 7 a.m. And we'll see how far we can go, maybe up to like noon. And then we have Mom and Dad. So Mom and sister leave at 7 a.m. in the morning. So they're at home at 7. And then an hour later, since they're driving at 45 miles per hour, an hour later, they're going to be 45 miles away. And since they're driving at a constant rate of 45 miles per hour, you're just going to add 45 every time. So they'll end up 225 miles away by noon. All right, Dad is at home at 7, so that's 0 away. He's still at home at 8. They leave at 8. And then he drives 60 miles per hour. So at 9, he's 60 miles away. At 10, he's 120 miles away. At 11, he's 180 miles away. And at 12, he is 240 miles away. Okay, so that's your table. Now, creating your graph, you need a title. So we'll call this vacation trip. We have time happening. That doesn't change. That is our independent variable. We're actually talking about literal time. I'm going to put 7 a.m. We'll have 7 a.m., 8 a.m., 9 a.m. Okay, and then that's a consistent scale because it's always going up by 1. And then on the y-axis, we will have miles, distance in miles. And it looks like the biggest number I have is 240. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes, 12. So it might be a good idea to go up by 20s. And before you do it, like with pencil, I always count it out. So this would be 0, 20, 40, 60, 80, 100, 120, 140, 160, 180, 200, 220, 240. Okay, perfect. But you just want to test it out just to make sure that it all fits. And test it out, you just have to count up. This is a consistent scale because I'm always going up by 20s. Okay, and then you're going to plot your points. So I'm going to make it a full screen so we can see both at the same time. We have, am I still right? Yes. We have 7 a.m. is 0 for Mom and Dad. I'm going to do purple for Mom and blue for Dad. Actually, I already messed up. because 7 a.m. is not right there. 7 a.m. is the next one over. Okay. So 7 a.m. is right here. They're still at home. At 8 a.m. they are at 45. At 9 a.m. they are at 90. At 10 a.m. they're at 135. At 11 a.m. they're at 180. And at noon they're up at 225. Okay, so that's mom and dad. Purple, I'm sorry, that's mom and sister. Purple is mom, this is your key. And then you take a ruler and you connect them. Now I'll make my line in purple so that it's consistent. That's mom. Okay, now dad is in blue. He is at 0 at 7 a.m. He's at 0 at 8 a.m. And then he goes up by 60s. So at 9 a.m. he's 60 away. At 10 a.m. he's 120 away. At 11 a.m. he's at 180. And at noon he's at 240. And blue is dad. Okay. I got a blue line. Okay, and then so the question is, when will Emilio and his dad catch up to his mom at dinner? And so, mom and sister, I don't know why I said dinner. And so this point right there is at 180 miles, and it is at 11 a.m. How do I know that? Because the point is 11, 180. And if you interpret that, that means 11 a.m. So we're literally talking about time and 180 miles. Okay. So that is how to figure out a double line graph. If I asked you how fast they were going, or the rate of change between A and B per se, which is one of the questions that I've been giving you on the warm-up, you would look at point B and you tell me, okay, that is the point 960, which means they've been traveling for 2 hours. So I'm going to put that at 960 for 2 hours. Well, it's really only been 1 hour, actually, because they left at 8. So 160. And so what that means is 60 miles in 1 hour. Okay, so 1 hour has passed and they've gone 60 miles. I can show you that again with the millimeters of water versus seconds. Between A and B, you can figure out that rate of change. At B, the point is 540, which means as a rate, it means 40 milliliters per 5 seconds. And then I can ask you what the unit rate is. The unit rate, 40 divided by 5, is 8 milliliters per second, or 1 second. Okay. What's the rate of change from B to C? It looks like it hasn't changed at all. So this is a 0 rate of change. 0 milliliters per second. Okay. So that is rate of change and how to make a double line graph.